Welcome to the Explainer. Look, if you've been in SecOps for any amount of time, you absolutely know the drill with traditional SIEM management. It is just so infrastructure heavy. It needs constant hand-holding, and frankly, half the time it feels like you're managing hardware instead of actually hunting security events. But today, we're looking at a massive, fundamental shift. We're going to break down the core competencies of Microsoft Sentinel and really look at why this requires us to transition to a true cloud-native model. We're talking about finally ditching the heavy lifting of servers and fully embracing automated log management, machine learning, and built-in tuning frameworks.
Okay, let's dive into this. Today's data journey is built on three main pillars. First up, telemetry lifecycle management. Next, high-fidelity event correlation. And finally, detection engineering and tuning. We're basically going to trace the whole path from raw log collection right down to those perfectly tuned alerts.
So, starting with part 1, telemetry lifecycle management, or as I like to call it, taming the flood.
Now you might be wondering, how do we actually balance the need for total visibility with, those licensed ingestion costs? Well, it all starts with how we grab the data. You basically have two main routes here, agentless and agent-based collection. Agentless is absolutely fantastic for cloud-to-cloud integrations. A prime example here is SAP. They actually migrated to an agentless data connector specifically to shrink their infrastructure footprint, which is a huge win. On the flip side, we've got agent-based collection. This is where you deploy the Azure Monitor Agent, the AMA, to your Windows and Linux VMs. You're going to use this to scoop up those essential Windows security events, syslog, and CEF data.
Just a super quick but absolutely crucial point here on transport protocols as our data starts moving. Anytime you're dealing with on-prem or cross-cloud streams, secure ingestion is literally non-negotiable. You have got to ensure you're using TLS encrypted syslog to lock down that data in transit, for sure.
All right, so our data is flowing securely. But wait, we definitely don't want to just blindly dump everything into our workspace, right? In the old days, you'd rely on a heavy forwarder to filter the noise. Well, in Sentinel, data collection rules, or DCRs, step into that role. They let you use KQL to execute ingestion time transformations. Basically, you can strip out irrelevant logs or completely useless noisy fields at step 2, way before they ever hit your workspace. This strategic pre-filtering is a massive game changer because it directly slashes those ingestion costs.
So, after the data gets transformed, where does it actually go? Well, Sentinel optimizes this whole lifecycle using a smart tiered storage approach. You put your primary high-value security data straight into the analytics tier. That's for your real-time monitoring and immediate investigations. But what about those high-volume, low-value logs? Think NetFlow data. You route that stuff over to the data lake tier. It's a brilliant strategy, honestly. It saves you a massive amount of money, and you don't lose that long-term retention you need for compliance or historical threat hunting. Best of both worlds.
Moving right along to Section 2, high-fidelity event correlation. Let's find the signal in all that noise.
So the data has landed safely and efficiently. Now Sentinel has to move way past those basic single event triggers to figure out what the heck is actually going on. The bedrock of this is stateful relationship tracking using KQL, specifically relying on the join and summarize operators. You aren't just staring at isolated events anymore, you're literally connecting the dots across entirely different streams. Like, as an example, you could join your VPN logs with your identity info and Azure activity logs. That lets you link a specific VPN session directly to some suspicious database queries that happen within 24 hours of that user being created. It's all about tracking state over time.
Now, what's really interesting about this slide is that you actually don't have to write custom KQL for every little thing. Sentinel packs built-in machine learning engines to do the heavy lifting. Enter the Fusion Correlation Engine. This uses highly scalable ML algorithms to look at multiple seemingly unrelated low-fidelity alerts and stitch them together automatically. Think about it. A suspicious login by itself, probably just noise. A mass file deletion? Could just be an IT admin doing some cleanup. But Fusion spots them happening back-to-back and correlates that whole sequence into one single high-fidelity incident for your team to investigate. And to make those stateful investigations even faster, Sentinel leans on the UEBA behaviors layer. User and entity behavior analytics essentially grabs all those fragmented, hyper-technical, super noisy logs and magically transforms them into structured, human-readable summaries. It's literally translating raw data into natural language that tells you exactly who did what to whom. It gives your SOC analysts that instant, crucial context they desperately need to cut through the noise and take action fast.
All right, on to our final stop, Section 3, detection engineering and tuning. Time to sharpen the lens.
The ultimate goal here is to maximize our signal-to-noise ratio by constantly refining our logic. And the absolute gold standard for this is the MIT ATT-ACK framework. Sentinel actually has a built-in page right in the platform to visually map out your detection coverage. Every single analytics rule, every hunting query, they should all map back to specific tactics and techniques. Visualizing it this way is absolutely crucial. It proves your SOC is actually out there hunting real-world threats across the entire attack chain, rather than just passively collecting data and crossing their fingers.
To keep that coverage razor sharp, Sentinel hooks us up with a really powerful continuous refinement toolkit. We're going to quickly fire through 4 key built-in tools: tuning insights, SOC optimization, summary rules, and automation rules. Let's break down exactly how these guys keep the SOC running like a well-oiled machine.
First off, let's look at the Tuning Insights pane versus the SOC Optimization dashboard. Tuning Insights is something you're going to want to review regularly, right inside your analytics rules. It actively flags entities, say a really noisy service account, that keep popping up in incidents you ultimately close as false positives. Then it recommends just excluding them from your queries. Easy. The SOC Optimization dashboard, on the other hand, zooms way out. It gives you these awesome AI-driven recommendations to tag your detections with MITRE tactics, and it actively warns you about coverage gaps that are causing real, tangible business risk.
Next up, we have summary rules, which honestly hit the nail on the head for this idea. Manage verbose logs without overwhelming analysts. Look, querying massive data sets over and over, it's slow, it's painful. Summary rules fix this by aggregating those giant data sets into clean, summarized tables in the background. It drastically speeds up your query performance and ensures your analytics rules are only firing off on high-level, truly meaningful signals.
And this brilliantly illustrates our last tool, automation rules. These are an absolute must for signal clarity. Let's say you've got an analytics rule that triggers during scheduled server maintenance every Sunday. Instead of forcing a poor analyst to manually close it out every week, you just build an automation rule. Step 1, it spots the known good maintenance activity. Step 2, boom, it auto-closes the incident. Step 3, because the system handled it correctly, your KPI metrics, like your false positive ratio, stay perfectly accurate without artificially inflating your team's workload.
So we've walked through the whole journey today, from telemetry lifecycle management and agentless collection, all the way to ML correlation and continuous tuning. Moving to a cloud-native model like Microsoft Sentinel isn't just about shifting where your data lives, it's about totally transforming how you manage it to get crystal clear clarity. So I want to leave you with this question to chew on. Take a hard look at your log management today. Is your SOC genuinely monitoring the entire attack chain using structured frameworks, or are they just drowning in a sea of unfiltered, untuned noise? Think about it. Thanks so much for joining me on this explainer, and I will catch you on the next one.